So I need just 1 minute. Okay. Okay, just a short introduction. Dear audience, dear Kevin Flanagan, in the name of Faculty of Architecture and Design, I want to welcome you to our second ArchiDesign Timber Talk of this term. Our faculty member, Forest Industry Specialist Demet Sürücü will be moderating the talk. Our guest, Kevin Flanagan, well known for his work about smart cities, sustainable buildings, and tall engineered timber structures. So, dear Demet Hanım, the word is yours.
Okay, thank you, Arif Hocam. Tonight, I would like to say hello and welcome to everyone, especially dear Kevin. Welcome to you. And I would like to add some words about who is Kevin Flanagan for our students and academicians. I have some notes. Please let me say about Kevin. Kevin Flanagan designed solutions resolve both the city contents and healthful environmental concerns in a single bold concept. His designs integrate man and nature in the responsible to the nature of place. He spoke most recently on the topic of timber towers and the vision for more livable greener city at the Council on Tall Buildings and Urban Habitat CTBUH 10th World Congress in Chicago. I think it was before the COVID pandemic in 2019. I know this event. And Kevin Flanagan is a former founding partner at PLP Architecture in London and a former senior associate partner at Kevin Flanagan New York and a founding member of Kevin Flanagan London with over 35 years experience realizing visionary award-winning design throughout the world. He began his architecture career in Montreal and Toronto, later working in New York for site environmental design architects in New York City, apprentice and architects, and Kevin Flanagan architects in New York City. Kevin was later invited to found with others in London, Kevin Flanagan office, have been with a practice for 25 years. He has lectured, exhibited, and published widely, particularly on sustainability and healthy cities. Notable recent works, The Age in Amsterdam. The project won, among others, the ULE Award and the BREEAM Awards 2016 for the both best office and the most sustainable building in the world, and the AIA Europe Sustainable Design Award. His earlier award-winning work includes the Grand Thornton Tower in Chicago and multi-award winning International High-Rise Award designed for the Hofteren headquarters for the Minister of Education, Culture and Science in The Hague, and the landmark headquarters of the Abu Dhabi Investment Authority in Abu Dhabi. Kevin has studied at Carleton University, Canada, the Architectural Association School of Architecture, London, University of Texas, Arlington, and through study scholarship in Rome. His recent projects have included the Oakwood Timber Tower series, winning the RIBA President's Awards for research with the University of Cambridge and Smith and Woolworth Engineers. I think that's all, Kevin. Okay, word is yours.
All right, let's see whether this works.
Okay.
How are we doing?
We cannot see it now, but sometimes it takes a few minutes.
Okay.
Yes, I see myself and Demet. That means if you,
All right, and that's it.
Can you make it extended?
Yes, yeah.
Okay.
And can you hear me?
Yes, I can hear you very well. Thank you.
Okay, well, thank you for joining. The talk is really going to be a little bit about COP26, because today is the first true day of the conference of international leaders with regard to climate change issues. So it's more of a think tank at that point. And they also are trying to establish new legislation that moves forward some of the goalposts that were set in Paris some years back. So that what I'm going to do is sort of rehash or describe some of the issues that are at stake, and then try to relate that to why timber construction, especially engineered mass timber, because of its great sequestering ability, would fit in well with plans to house a doubling of the size of the population from its present in many cities. So the idea is to use timber would have great impact, a positive impact in terms of CO2. But there are also some later slides, if time allows, to describe the psychological benefits that have been found, because there are lots of studies that have been done in Chicago and Toronto on using the material and in an urban setting, how that can make us healthier. So of course, we're talking about a tree, interesting thing. Now, interestingly, Queen Elizabeth was to attend, and she gave her reasons for being irritated by world leaders who don't do anything, just simply talk. And that is generally the feeling in advance of COP26, is that the world leaders may or may not be able to manage to move things very far forward. But in any case, what I did in advance of the event was try to propose something that could be built very quickly out of timber in the 5 months prior. And the bigger issue really was to see whether new ideas could be brought forward, because construction, particularly steel and concrete, make up about 23% of the materials used, and whether there's an alternative that might be suitable. About 40 to 50% of all CO2 actually has a lot to do with the use of the materials and also the life cycle use of energy. So this is a diagram of where we were if we had been using pre-Paris guidelines. And we've done pretty well, but we're actually, in terms of policy, a lot of pledges were made, but they have yet to come into an effect. So in order to maintain the 1.5 degree centigrade heating of the planet, which actually is accelerating faster than people thought, we're only really about halfway there. So, and we have about, we don't have very long until, this is a bit of the problem, that things are not moving fast enough. But what would be the effect if global climate change continued as it does and the planet heats? Well, one of the effects is that the ice caps in the north and in the poles will melt, and the effect would inevitably be the flooding of major cities of the world. In fact, London is one of the great cities that is going to be most impacted by the flooding. New York is another city as well, should the ice caps melt. And you can see basically New York disappears, about 50% of the place disappears. St. Petersburg is another city that's highly at risk. In fact, it's common to have flooding there. And they have built a dam, but like any great engineering feat that tries to control natural water rises that are going to be so extensive that it may not be the final solution for things. And at the same time, Istanbul as well has got concerns in terms of flood risk presently. The other thing is that within the 2 miles from the coast is those areas of land represent about 60% of the country's GDP. So flooding is going to have an impact. Now, one of the things that's interesting is that there are some reasons why we haven't really moved forward very quickly. And one of them has to do with a certain way that people are, the way that we think, and the way that we handle new information and new challenges. Very often people believe they know more than they actually do. And it's a problem if people also don't believe in the science, in facts. And there's even a term for it, Dunning-Kruger effect, where people tend to believe what they shouldn't really believe because it makes them feel comfortable. And the second is the problem with our love for present technology, which is very often 19th century technology. So this is a compressive force of a piston running on gas. And gas is one problem, but the piston itself is drawing in air with certain particle size, and the pistons pulverize that dust and creates even still finer dust. And it's that very fine dust that actually is causing a problem for the Himalayas particularly. There have been lots of studies done, and it disrupts, this very fine dust actually disrupts the formation of water and snow crystals. So though there's been a lot of discussion of glaciers melting because of the heat, and as it melts, the darker particles rise, and air pollution properly. But there's another thing, is that the glaciers are not being fed further, more ice, that even that the production and creation of ice crystals that would build up the glaciers again is not occurring as it would have normally done because of the fine dust. So that's a problem, because about 1/5 to 1/4 of the world's population depends on the Himalayas for fresh water. And presently, directly, about 250,000 people require the water for bathing and drinking. But once it's disrupted, it doesn't come back. And the aquifers, of course, are going to be depleted at the same time. So that's a serious concern. It has to do with global warming, but also has to do with the technology that we're using presently. The other funny thing is that people don't respond to things that happen very slowly on a lifetime basis. And I'm using a very crude example here, but we have had increases in CO2 and the effects of global warming now since the 1980s, when Margaret Thatcher made quite a long speech at the UN. Very good speech. She was a chemist, so she understood some of the particulars and the challenges. But since the 1980s, things have not really moved so terribly fast forward. And part of it has to do with the public's belief that things are not changing when they are. And it has really a lot to do with how slow people, if something happens throughout their lifetime, they don't really recognize it. The other thing is that the oil industries here, particularly because they're under investigation in a sense, have intentionally created disinformation. So anything that happens that would have caused people to think maybe this would be a good time to make changes, there's a counter argument always that says that things are okay, that what you believe is not true, that you know, that the public debate really becomes very muddied. And you can see this in some of the very odd beliefs that Americans hold even to this day. Article on how do you create a collective sense of urgency? How do you bring people together? And this article made the case that science seems to be saying that if you can make people understand that they're living in a single world together, and also that they begin to have an emotional investment in that world. So they went on to describe this sense of awe that people, in order to move things forward properly together, we need to see the challenges, but also the sort of benefits that nature and the world around us provides. And that will develop a certain intellectual empathy and emotional engagement. And from there, then people collectively can move forward. So the strategy at present, though, is to disrupt that creation of a cultural collective sense that there are problems that need to be solved by creating inflammatory and sometimes negative comments about, newer technology arising. So this is a quote, I'll just go through this quickly, by Albert Einstein, talking about how wondrous the world is, and that it's important to capture these moments of awe, the setting sun. If you're ever on a plane, it's wonderful to see the curvature of the earth, to look at the clouds. One of the things, though, should be understood is that we're in a new age. We're no longer in an industrial age in the sense as it was when I was born in the 60s. Things have really changed significantly. We've gone into a digital age, and man now occupies a place at the highest pinnacle of the animal kingdom in the way that it had never done before. We're also living together to a greater extent in cities. And these have repercussions along with what is going to happen because of our newer connectedness through our mobile phones and other systems. And a lot of people really are discussing how we can live differently. Our diets could be different in order to sort of survive this newer world. There was just an article by a Sir David King in London, and he was describing that we only have the next 5 years to really start solving these problems in an important way, or they will tend, the events will overtake, and we will begin to describe how our lives will be over the next 1,000 years. So there is some interesting points about COVID as well, is that, I guess you guys have seen as well, with so little industry, skies were much, much clearer. And of course, there's a difference between 2019 and 2021, where you can really see the stars in the sky in a way that wasn't possible before. And that has a lot to do with atmospheric pollution from cars and from factories and those sorts of things. The wonderful thing about cars and factories is that they've been a tremendous success to the, providing new means of transport, but they're also 19th century, early 20th century notions of how we should be living. And their great success, and also the use of certain building materials, their great success has meant a huge had a huge positive impact. But because they've become so ubiquitous and have created a very homogenized method by which we transport, by which we build, their great success also means that, of course, the materials have deficits. And it's those deficits now that begin to add up to create more problems. So if you had a ton of concrete, it's saying here, basically you have a ton of CO2, but by contrast, if you have a ton of engineered mass timber, it basically saves and sequesters about half a ton of CO2 broadly. So you can sort of see if you use a different material, if you can find a different material, then it might be better because it can sequester CO2. That's what timber does. I'll go through these really quickly because you can look at them later. But it's interesting. So we did studies with Cambridge University with all this in mind, that we needed to create new cities, and this should work. I don't know.
By 2050, the world's population is expected to soar to almost 10 billion people, and 2/3 of us will live in cities. Space will be at a premium. High-rise offers a solution, but concrete and steel, the materials we currently use to build high, have a large carbon footprint. An answer might lie in a natural material we've used for millennia.
I think it's very realistic to think that someone will build a wooden skyscraper in the coming years. There's a lot of potential that's unrealized for using timber at a very large scale.
Throughout history, buildings have been made of wood. So why, after more than a century of concrete and steel, are some architects proposing a return to wood? Concrete and steel are costly to produce and heavy to transport. Wood, however, can be grown sustainably, and it's lighter than concrete. And crucially, as trees grow, they absorb carbon dioxide from the air, locking it into the timber. One study showed that using wood to construct a 125-meter skyscraper could reduce the building's carbon footprint by up to 75%. Regular timber isn't malleable like steel or concrete, and it isn't strong enough to build high. But engineers have come up with a solution. It's called cross-laminated timber. And this London practice is not alone in advocating the use of CLT. Ambitious wooden high-rise buildings are also being constructed in Scandinavia, Central Europe, and North America. As yet, nobody has used CLT to build beyond 55 meters. But Michael Ramage's research centre in Cambridge, working with another London practice, has proposed a concept design of a 300-meter tower to be built on top of one of London's most iconic concrete structures, the Barbican.
The way we've engineered the Oakwood Tower is to look at the global structure and is it stable and would it stand up? And we believe the answer is yes. I think we'll probably see incremental increases from the current height of about 50 meters. And at some point, someone will make a step change probably to about 100 meters.
Making that jump in height will be a difficult sell. The cost of building wooden skyscrapers is largely unknown, but those costs could be reduced by prefabricating large sections of buildings in factories. And city dwellers will need to be persuaded that CLT does not burn like ordinary wood. As an attractive natural material, wood is already popular for use in low buildings. If planners approve, it could rise to new heights.
So when we look at cities, of course, there are physical aspects to cities, but also movement aspects. So this is the city of New York through the day. It has a day and night, and weekends are different than the day. And it's that idea of looking at cities rather more like a natural organism, a collective of people and their movements and desire lines. And the notion that as real estate developers like to think that they have lots that are quite independent of each other and not really intended to be synthesized into a better, more efficient whole. So when we look at cities, maybe the way that we look at it should change as well. Because what we're trying to do now is see whether there's any benefit in looking at cities rather more like a natural system and a little bit less like a physical series of monuments within gridded condition. So that's the circulation. So let's make the cities more comfortable, pleasurable. And since COVID, you know, we understand why that's important because we were all in lockdown. We all needed to go see green spaces as we did. So how do we create these healthier cities? So under COVID, what's broadly changed? Quite a few things have changed, and they're going to change the way we see the world quite profoundly. It was the same case 100 years ago with the influenza virus. People's socializing changed, and also as we see people's working habits have changed and necessity. But one of the interesting points is they found is that if you could stay one day at home a week, your efficiency and productivity increased 13%. And for me, that kind of tells you there's something wrong with modern office buildings. The concept of them, the hierarchies that exist within them, within companies, that they're not allowing people to work to their optimal. And therefore, people tend to be unhappy to some extent working in these buildings. So it's almost a prison that we've created of our own devices. So now is a good time, while COVID is still disrupting the world, just look at these things in a different way and see whether we can make things better. So 57% appear love to live at work at home presently, but actually 2/3 of the people within office buildings typically are millennials or will be, and they, by a vast majority, want to work from home, whether it's every day or, but certainly not as we did before. Work habits will need to change to accommodate new preferences. So that's interesting to look at buildings. Well, what's really wrong with them? Well, there are a number of social problems with them. The internal core is one of them. And of course, for COVID reasons, the present building designs don't allow for anything near the 2 meters or even 1 meter that's required. So the capacity of the lifts can't manage the populations any longer and won't be able to within a safe condition. Now, we all might say, oh, well, COVID's going to go away. We don't have to worry about this, but that really doesn't seem to be what will happen. I think we've opened up a new world of challenges, and maybe the designs of the buildings need to accommodate those new challenges so that people feel safer. The other problem with building plans with the center core is that, and this happened to me, I knew there was somebody who was working in the company on the floor, same floor as I was, but for a year I never saw them because they were at opposite ends of the building, and the core itself meant I never had any direct view to be able to see whether the person was actually there. So it's a better idea in a lot of ways to try to distribute the core through the floor so that these social engagements happen more easily within the building floor plate. And that is somewhat what happened with the project in the Edge. This is just a diagram. And that's the Edge there. It was the world's most sustainable building, and thought quite cool. And it's one of the best examples of Internet of Things. This is just showing the wood was used, that people enjoyed it. There was 2.5 times more sort of sticky applicants wanted to stay and work in the building. There were a lot of benefits in terms of wellness. It won lots of awards. But one of the things was that the open space, the atrium, was quite open to views to the outside, to nature at large. And there were changes during the day. There's one thing about buildings is that we have so many mechanical systems that monitor a constant state of temperature and light that people actually get bored working in them. In other ways, they've been perfected to such an extent that they don't cater for people's desire for change, for views of green, or changing situations within the floor plate. So that's why, in a sense, the atrium of the Edge was working so well. So this is an early urban designer describing how we should be trying to design things that are less stressful. And that's because we want people to have a joyous experience going into these offices and a joyous experience living and working in their cities, and transport as well. So looking at different types of city plans, Chicago's a good example, and Toronto, oddly enough, is a good example of, in a sense, what needs to be done to improve things. As far as transport, people spend a phenomenal amount of their lives going to and from work, from suburbs. The public transport within the city core is good, but once you move out of the city core, as most people do, the transport into the city is terrible. And the people spend about 3 years of their life, working life, in their car. The other problem is that because people spend so much time in their car, the air quality is quite poor. And that's true in a lot of cities. And this relates somewhat to COVID, that airborne particles that are very fine, as we described earlier, have been pulverized by internal combustion engines, cause a very fine dust, and they get into people's lungs and cause death, premature death. The other thing that should be understood too is that the demolition of buildings for cities that are very vibrant in building and rebuilding, every time a building is demolished to build a new, the silicates from its concrete and other fine particles also are distributed into the air. And the silicates are been found to be cancer causing. So again, a problem with air quality in cities has a lot to do with the materials that are being used. And there was a study recently about premature deaths in Europe. So about 250,000 people die in Europe due to the fine dust. And many on a yearly basis in France and in the UK, from what I could find. So perhaps what we could do is look at electric cars, yes, without the internal combustion engines, and also to create green spaces within these cities that will act as lungs to purify the air, as they did in 19th century London. They would have plane trees whose bark would fall off in order to allow the tree to breathe properly. And that's a great idea for autonomous cars. And of course, we could think of cars in a different way. We could think of cities in a different way. How do we green them, particularly along the coastline where people like to walk typically, because there's a changing light and a character of openness and distance and skies, broad skies, which you don't find in urban conurbations, which tend to be quite dense. So going to the waterfront is always a lovely experience for most city dwellers. The other thing Toronto is doing is trying to create pedestrian linkages within city blocks. And Barcelona, though, is one of the cities that really looked at air quality as a big problem, because it is a problem for them. And they started to establish studies of how they could create super blocks where the pedestrian movement is given preference over cars. And that is ongoing. I just read a study this past year. But the bigger thing is that really, I think our minds have changed. When we look at the things that we thought were very advanced in the 20th century, they now look not so advanced. And it has nothing to do with their being preferred in the 20th century. It's just simply that we didn't have quite as many of them. The industrial economy has really now become a global fixture. And their pollution has also been now a fixture. So problems that we may have had that were small and easily handled, or because of their success, have created bigger problems that sometimes are unmanageable for us. The pollutions of streams and those sorts of things. So in the 21st century, certainly for my children and for millennials proper, they see, well, why can't we use natural products more so than industrial products? And this leads on to marketing of apartments for millennials, basically, where they can have a balcony and private space and can see wood and timber and natural material that's pleasant to the eye. And it has some benefits as well in terms of air quality within the building. And of course, these are simply taking further ideas that came forward from an architect in Canada, where timber is pretty ubiquitous. But they've also found that using this material, because it's so light, will reduce in city centers the require for piling and for foundations, which typically take several months to complete. And of course, if you have existing tunneling, you need to engineer your work so that they avoid those tunnels at great extra expense. So there's time and extra expense. And so you could make, if you used a material that was strong and light, you could save some money. This is a wonderful early project, which we used as a template. And what was interesting about this, 50 meters, was that really it was based on a bridge that had been set vertically on its side. But there was also further discussion that they were also studying in a similar way, a 100-meter tower. This is my mocking up of that idea, just for illustration. But in the industry itself, what's happening is that they've taken this notion of timber buildings and simply redressed concrete cores, structures, and floor structures. with some timber. So you can see here the image in the middle is basically the structure, the fundamental structure of stability system is actually all concrete. And in the plan, you can see that as well. It's concrete, concrete, concrete. The columns adjacent, and even the floors were poured or planned to be poured in concrete as a topping to the wood planking of the floors. So it's not going to really benefit the CO2 discussion so terribly much. It'll benefit to some extent, but you know, it would be better if we could manage to build very quickly, as this illustrates, but without that concrete core. So you get the general ideas that what I'm saying is that the hybrids are good, but they're not really helping as greatly as they could be if it was made quite all out of a single material. Both structurally, there's a benefit, and also in terms of time and potentially cost, depending on the cost regimes and the expertise of people using timber versus the concrete. But you can sort of see that there's planking, but also there's typically some kind of overtopping of the concrete to the wood planking as it comes in. So hybrid slabs are coming to the fore in Germany particularly, but they're not going to save so much as we had hoped. So when you're using timber, which is a weaker material, for high rises, you need to think of the core position. And again, we earlier described how the core position in the center is not so good socially in terms of building use. And so it's not really catering for human use nor human interaction. And that's a very great disbenefit when the cost of your company actually is in its people. So moving the core away and making it weak, in a sense, is a strategy where you put the stability system of that's required, would have been required for the central core, putting it to the outside. And this is what trees do as well. In nature, you'll see that it's the distance between the two major supports that provide the stability and the bracing. These are just slides that show how air can be moved through, because of course air is a significant factor in COVID, and really needs to be solved in order to allow people to feel safe to go back into work. And there are new systems, particularly for timber, that will allow this to be done happily and easily enough. And some further slides. This is a proposal for Toronto, a building in Toronto. And I think this is just a slide that shows. I can leave the PowerPoint so that you get a sense of what they're planning to do. A series of timbered layers. So these are also just mentioned in Toronto, that it's a sort of unusual because the amount of concrete's used, and of course there's more than 50% that's being built for residential. So it's an anomaly in a way, and easy therefore to understand why that industry is there so favorably. The use of timber also has its processing has lignin and other elements that can be used for bottles rather than those that are presently used for the refining of oil and gas. And they tend to be biodegradable, rather not like those that are used with oil and gas manufacturing and refining. So that's a benefit, and certainly understanding now that we are ingesting bottles and polymers, and it's having an effect on our health. Probably a good thing to think about as well at the same time. These are slides from a Kintera article. They've now don't exist as a company longer, but what it's trying to do is show that being able to digitize the supply chain has benefits, and for them using timber was a good material for creating buildings that could be made out of component parts. This is a quote actually from Mr. Anthony Thistleton, where he said that if they did a study for a building in London, they found that if it were done in concrete, they would need 900 movements as opposed to 100 movements if the building was built out of timber. And what he was really doing was saying to the neighbors of a building and to the planners, you know, building with component parts is much less disruptive to the neighborhood and tends to be quieter, and therefore it is also one of the benefits of using timber planking, quite large timber planking. So for me, it's the foundations and also the fact that you can build much more quickly. There's a lot of extra planning that goes on in advance of building these timber buildings, because they tend to be built kind of like a mechano set. They're assembled. They need to be assembled in the computer and properly cut. So I've done some studies. This is just one of them, which I just mentioned. The other thing is, just as an example, because I saw this last week, I guess, and thought, my gosh, that must use a huge amount of steel and concrete as a building. So let's say hypothetically, it's 800 tons of CO2. It might actually be 8,000. I'm not sure. But if it were made out of timber, maybe if we also looked at examples in nature where natural forms are brought together in a certain way, could we make a hypothetical tower that sequesters about 400 tons rather than creates 800 tons of CO2? And beyond the sequestering, because we're not using concrete, in a funny way, we're also making the savings from the fact that we're replacing concrete with another material. And so you could get, presumably, whatever the plus figure would be, you would gain a negative. And that may not mean very much to people, but if we think of the number of new residential buildings for a growing population, which we have, then it's going to be quite significant. So I think I've got enough time to do this. Other slides, I'll just go through this really quickly. Do I have enough time?
Yes, you have time. Thank you.
Okay, okay. So one of the things that the Chicago study, because I spoke in Chicago, I did some studies of what they had found. And in terms of biophilia, or being surrounded by the view of timberland or green or parks, is that they began to understand that people were greatly affected in a positive way when these things occurred in cities. So they had a building that they studied where all the windows looked onto concrete buildings and concrete walks and concrete parking garages. And there they found the inhabitants much more on edge, much more antisocial, having more medical problems. But the other two sides of the building looked onto green spaces and trees and probably had the sounds of birds and the living things. And they found that they were much more sociable, much more at ease with themselves, did not take offense as easily, and were much more cooperative, and which is what you sort of want in a city center, where you have everyone compacted among themselves. They were sort of the peacemakers in the building. It also improved creativity, and absenteeism was reduced in their office buildings. So bringing these features together, it sort of suggests that if we can bring this timber material to buildings internally, and even if we express them externally, we're going to have a profound change to the psychology of people within cities. And this is really interesting because it's a material that not only sequesters CO2, but actually changes our minds, changes how we view ourselves, and improves our sense of well-being and our health. Our blood pressure reduces, and we are much more cooperative, all these wonderful things. And there was even a slide here that mentions that if you can manage to pull all this off, then the temperature of your streets is reduced and people enjoy the cities much more. And it's a really interesting, I'm going to leave this for you, but there was also this idea of impulse control, that people that have a hard time in cities, and you know them because it's typically people who have road rage, they seem, if they come from an area or they're living in an area where they have the ability to see green spaces or parks, their involuntary reactions are improved. And the reason is that, so one of the reasons why people say, well, why is that we like trees? I don't know. Well, there is a reason, because we actually have two brains. We have the involuntary brain, which is basically our spine and our sort of higher cognition function, and which we call our brain. But it's that sort of brain stem going through the spine that needs, apparently, to see green practically every day, not for too long. And without seeing it, we have negative, there's a negative effect. So in a funny way, if you think of it, we have evolved from forests. We have evolved from seeing green spaces, and cities are a new thing for our species. And it's that fact that we benefit from seeing green, and it has a much healthier effect on us than looking at concrete and steel. So it's an interesting thing. More sleep, all these other funny slides that I have. So that's interesting. Green cities, there's some benefits when you use the material internally, which I'll leave you slides of. And then this is these are the slides for the timber tower, which you can go through at your leisure. There are animations that are tied to it as well. But it's really saying that we can grow these buildings within a very short period of time with the stock of available material in Europe, about 2 hours roughly. And the engineering's possible, still needs some investigation, of course, but the use of robotics and jump factory staging, which was a proposal by Bouygues in France when we had some meetings with them, would really allow us to build these very inexpensively and fast. Okay, so this will take another few minutes. So the other scheme was in The Hague, which had an externally braced system. It was studied to some extent because they were planning on selling the apartments. The one thing that was interesting is that the city fathers allowed the client to go up about another 20% higher, from 80 to 120, because it was a new material, and it would create the city planners, and the city would be associated as a vanguard of this new technology, and quite a beautiful building on quite a narrow site. So there you go. The external bracing actually shades the internal. There are the decks and balconies, the upper lounge area, bars, and I'll just go through this really quickly. And this was in the press as well, as it was said it would save about 75% on the typical footprint. So one of the things I'm really saying is that the material could allow us to go negative in a sense, because we have to reach zero and our population is rising, without sequestering and some of these very dramatic methods of capturing CO2, we're not going to meet any of the goals, because it's a mathematical difficulty when your population's rising. At the same time, you have what are third world countries now becoming second and first world countries. And of course, if you can save a huge amount of tonnage of CO2, it also represents many lifetimes, human lifetimes. So I quickly calculated that if we could build many of these buildings, it wouldn't be too difficult to sequester half Europe's population in terms of lifetime CO2. And that's what these other slides are trying to illustrate as a notion. We did some other studies to go really through quickly with these, and that's it. Ta-da! Okay. So I'm done.
Thank you very much.
Okay.
Thank you, Kevin. Thank you.
Okay. Okay. So other questions or?
Yeah, I'm waiting.
Dear students, do you have questions? Yes, Abdul.
Hello, can you hear me?
Yeah.
Yes.
Yes, thank you for your presentation, sir. My question was that, yes, this is very effective and very useful, but how could it be the reason that it's a strong material like timber for high-rise buildings? And for example, if we use concrete or steel, we know the strongness of the materials, but how can we be sure about this material? Because timber and steel, they are not comparable. I'm just a little bit thinking about this issue. So if you can explain me.
I don't know whether I have the slide here, but it's in the presentation. By weight, what we're using is an engineered material. So it's not like using wood beams. These are made up of glue lammed. Effectively, they're glue lammed in cross fashion at each layer. So they're terribly strong, but they're also very consistent. And because they're so consistent in its calculation of strength, it can be used in a fashion that wasn't thought possible earlier. This is something that was developed in Australia a few years ago. And it's only really come to, in the 21st century, has it really come as a material that has got, proper studies been made for fire and strength. And so what we found, though, is that I think I tried to show in diagram that when you have center core concrete buildings, it's not necessarily, if you go tall, it's not the best solution for that structure. The best solution is actually after about 200 meters, 150 to 200 meters. You really should be putting the externally braced system because there's torsional load and wind load that overtakes any loading that has to do with gravity load. So, you know, using a material like timber on the exterior of the building actually gives you pretty good results for a high rise. In seismic zones, Istanbul's in a seismic area. Lighter materials are more robust. In effect, they're safer, and the taller and more slender type of silhouette for a building is also safer because it moves with the seismic loading, but it doesn't have that inertial energy that a concrete building has. And you've probably seen buildings from videos in Japan where the buildings are smashing each other apart, they're breaking each other apart because they're clashing with each other. But it's considered a pretty strong material, strong enough to be used in high-rise. But again, you really have to think of the buildings in a completely different way than you would to an international style block. That's why you can sort of see it. There's the bases are wider at the base, and as you taper, you sort of taper as you rise, or the external shape is sculpted in such a way that the wind movement across the building is lessened. So it's a different material. Every material, like people, have their strengths and weaknesses, and you really need to design based on a new notion of what's best for the material. But by weight, this is what people always say, by weight, it's equally as strong as concrete and steel. But it's just simply such a light material that you have to create dampening in the building. That's why in the towers that you see, there's green spaces, there are winter greens that are actually used as the dampening mass dampers for the towers. But it's early days. You have to build some of them. Some of them will be built in Scandinavia, but most countries have a lot of timber available that they're not using. They're just letting the bugs eat them. So it would be a good use of material and would reduce your CO2 footprint pretty considerably. That's the notion.
Thank you. And one last thing.
Excuse me, can I interrupt you very
Yep.
short?
Yep.
Mr. Flanagan, can you stop sharing the screen and maybe turn on your camera? We cannot see you. We see your screen at the moment.
Okay. Is there anything wrong with it? So do I stop?
No, this is nothing is wrong. If you can stop sharing.
Stop sharing.
Yeah.
Can you see me now?
Not yet. Maybe.
Take a minute.
But it takes a minute mostly. So.
Okay. Okay. There you go.
I cannot
Camera
see
on.
you. Okay. Thank you. Thank you very much.
Okay. I'm sorry I can't see the fellow who's asking the questions. Does that answer your question, or you said you had a further question?
Yeah, thank you so much. One last question. What about the lifelong of the materials? How long does it exist if we make a building with such a high height? So if you can...
Okay, well, I'd love to answer that one. I think in the pyramids, are what, 5,000 years old, and they still have cedars of Lebanon in them. The point is that they need to be cared for. They need to be reviewed. There are buildings here in London that are 500 years old, all made from oaks, but you need to be sure that the bugs aren't at them. That's easier done now than it was. Yeah, they need care and concern, not so different to other materials either. I'm in a residential apartment here, and there's a crack that's running all the way through the floor, through the wall, through the ceiling. It's like, somebody really has to come and look at this, because of course there's some of these buildings are slipping into the Florida Everglades. So, you need to maintain the building, you need to supervise them, and the same would be true with this material. So it could last quite a long time.
So Münir. Hello, Münir Mohammed. Okay, is there other questions? Because Munir is raising the hand, but there is no voice. We cannot hear him, I think.
Can he type? If he can type.
Yes, maybe he can type.
You could even ask in Arabic. And
now we cannot hear you, Munir. Maybe you can type, okay?
He's got his microphone off, that's why.
Okay.
I can see all the patch.
In the meanwhile, I can ask a question. This is still not very clear to me. I'm thinking always on that. Let's say we have glulam or CLT. We have a building and we are storing CO2. After the lifetime ends of the building, after 100 years, it doesn't matter. We cannot burn. Can we burn or reuse this material? Are there possibilities to work also, because these are glued, these timber parts? Okay.
Yeah. It's biodegradable. So unlike, I think there was a slide that said about 20%, it may be much higher, of all landfills are actually concrete. So typically the concrete buildings are demolished, and it's hard to reuse the elements. That may change over time. And what I think most people are thinking is that we should develop, just as they do in Japan with tatami mats, you develop a size that's a common size so that those elements can then be reused in other buildings. You know, humans have a certain scale, certain size. So it's not unimaginable that you have a kit of parts that can be reused in 100 years. Certainly they can be turned into pellets. But that's the second use is something that will be developed as the technology. It's very early days for this technology. So, you know, what I'm trying to do is promote it as an alternative for review so that, you know, it can be studied to a greater extent than it is already. And the only good way of doing it now, since a lot of the lab testing has been done and the fire testing has been done, is really to build them. I think what will happen is that they'll find that it's a different type of living that people have to get used to, because the elements of the building will, under wind, will move because they're dynamic and they may make noises. Or if you've ever been in a boat, it will feel a bit like that. It'll be a dynamic, safe, moving kind of thing. It will have its own dynamic of that. And there's always engineering principles that can be used to mitigate these things. Just like steel and concrete have deficits in terms of their sense of comfort. But you know, if the market moves in that direction,
okay,
it would be a good thing.
So I think Munir's question is here, but Munir, I think this question is already answered. So what is the difference between oak wood and CLT?
Well, cross-laminated timber is an engineered material. So if you look under CLT for videos, or go to, there's a really good video that Cambridge has put out related to, if you type in timber towers,
maybe
the Royal Society has got them. Yeah.
They can find videos on the web about CLT.
Right. That's right. Yeah. But how it's manufactured, there's some videos of how that's done.
Yeah.
Are there any other questions?
Yes,
dear lecturers, dear students.
We have a question, I think, Elif Hocam, from...
This was Munir. I don't see any other hand raising. Okay, there there is a question.
Rita.
Mariam. Hello, I want to ask about the reason we don't see the change in construction from concrete and steel towards timber as heavily as it should be. Why is the market scared or taken aback from this new structure solution that is very positive towards environment? So she is asking, why are we too slow?
No, yeah. So if you go to Zurich, you'll find a lot of concrete contractors are now using this material, but it takes a little bit more speciality than you learn in school. The bigger problem is that engineering degrees are really based on concrete and steel, and the new structural books that are going to be needed for designing, particularly high rises, are not yet in place. You know, Cambridge are doing some studies, their PhD students are doing studies, but you really need schools for this material. And the contractors that build out of concrete and steel presently, that's their expertise. But also, they've very often contractors buy materials 10 years, you know, down the road. They commit themselves because the concrete is made in factories. The factories need a certain output in order to be profitable. So the contractors very often say, I'm going to use concrete for this material. They pre-decide 10 years earlier materials they will be using for the stream of projects as they envision them. So to change the culture takes some time. But also we found that just like Elon Musk is now the world's largest car manufacturer, he's not using internal combustion engines, he's using electric engines. So it takes some time for that new methodology to become acceptable. He had the advantage, the car on the outside looks like all the other cars, you know, but we have a product that looks different and does have these advantages and some disadvantages. But we found in Scandinavia particularly, young people want to use this material. So it is going to change the marketplace there. And hopefully then, as you are saying, what we find is that millennials are a little bit more ethical about the choices they make. And because you're young, but also you have grown up from this concern about the planet at large. So, you know, I think it's up to you guys to tell the people who are selling your building, I don't want to live in a concrete building anymore. I want to live in one that actually is made of this material. And you have a great timber culture in Turkey, and all those wonderful buildings in Istanbul particularly, which are timber elements, but you know, it bespokes this notion that you're a country that lives in timber woodland, surrounded by nature and rivers and streams, and it's part of your national heritage to use this material. And I've got to say, in some countries they're landlocked, so they don't have a navigation history. But for countries that do have a long history of navigation, what I find is they adopt and adapt the notion of using timber much more easily because it's safe. They think of it as floating. You know, you're going to save your life by living in a boat. By using timber, that has a very much more positive association. But again, when I visited Istanbul in the 1980s, so many years ago, it was really those timber buildings that really I was really struck by the quality of them and by the evident joy that the owners had in creating them. So I think it's a good material for Turkey.
Yeah.
Yeah.
Thank you, Kevin. Thank you very much.
No problem.
Okay.
Any other questions? There's somebody with a little hand up here.
Yeah.
Yes,
Nilay.
Nilay Hocam is raising hand.
And thank you very much, first of all, for the very informative and inspiring presentation. I have a question about engineered timber. As far as I know, specific trees are used for this, and as you have mentioned, I don't know, generally the examples are in the northern countries, so it made me think that maybe a specific climate is required for growing such trees or not. I mean, is there an improvement in that side of the engineering? I mean, is it possible to use different tree types and produce engineered, timber? Because this seems to be a kind of excuse for many countries, as if, I mean, not all trees are not suitable. So thank you very much.
David might answer, but I'm going to answer first. They typically here they use ash, and why that is, I guess it's because it's easily available. When Cambridge is doing studies and they talk about timber buildings, they're also looking at grasses like bamboo. And there are a lot of conferences now on using bamboo. There are some distractors. There's a difficulty, but it's very strong and it grows quite quickly. You can use pine, which is what they've studied, but it has a lot of gum in it. It has a lot. There's a problem with the gum because it affects the adhesion of the modern adhesives now have been developed for another purpose and now are being repurposed for cross-laminated timber. But schools are studying more natural, less profoundly challenging sort of adhesives. And I kind of think what will happen is that eventually, if this really takes off, that we'll actually create a hybrid type of tree for the purpose, and that will have different compatibilities one to another. Different trees have got different sizes of their molecular kind of form as they've evolved. So putting one type of wood adjacent to another sometimes is a challenge because they have different modulus of elasticity but I think over time that will no longer be the case, and we'll have materials. I'm always, I believe in technology, so I always think if people really want to use this material properly, they're going to do a few things. One, they're going to make sure that the timbers that they have and cut down today are going to be available to the future. They're also going to know that the wood is going to be of a higher quality, better strength, if the surrounding nature that allows it to grow is secured. So that means, creating not homogeneous as they do in Canada now, but a diverse environment for these trees to grow, because the trees actually need animals to grow properly for the nutrients. So I'm a big believer, if it's really good, people will work at making it the best, and we'll have to see.
Thank you very much.
No problem.
Maybe I can add some things to Kevin for Nilay's question. Yes, in Europe, how we are manufacturing engineered wood products like glulam and CLT, we are using spruce. Mainly we are using spruce because spruce is a timber species which can be plantation forest. It comes from plantation forest, not from natural forest lands. So spruce is the main species we are using for wood, industrial wood products. But as Kevin mentioned, we can use different types of different timber species. Maybe we would like to manufacture CLT. Outside of the CLT, outside the CLT can be oak if you have a budget. If you have budget, because every depending on timber species, timber can also have a different durability. Durability to climate conditions, has different mechanical properties, and it changes change the different types, different spaces change the behavior on the building behavior for earthquake behavior or other loads on the timber building. They change the bands to timber spaces. So spruce is the main element, main timber.
Thank you very much.
There is one more question I see. Afaf is asking, what about factories where such materials produced and the technology is used? Can it cause more pollution more than what we intended to get rid of? So she's, I think, afraid of that the production of engineered timber may cause other problems. So
who wants to answer that one?
You are speaker. You are, yes, please.
So there are some processes in the making of the timber. One of them is drying the lumber. I used to be a carpenter, so you need to season the wood, and that takes some time because you need to get down to I think it's less than 20%. But the timber typically has a high water content, and presently for any type of wood, they use a method of drying the timber, which really uses the dust and the remnants of production into cutting, and that causes a release of CO2. But I also think that there may be other ways of drying the timber in a manufactured scale. One of them would be, again, we were talking about the pyramids, we could use salts possibly to dry the timber in some kind of a line fashion without having to reburn and release further CO2. You could put the timbers to season them into deep mine shafts where the temperatures rise to the 80s to 90 degrees, very hot, and that would dry the timbers as well naturally. And I'm sure there's other ways of doing it. So there are challenges moving forward to a production scale, because I'm not just talking about building 5 or 6 of these in Europe. In order to manage the CO2 and really sequester to the scale that we need to meet Paris, the Paris Accord of net zero, we're going to have to build thousands, tens of thousands of these things, and it will really have to be supplanting a lot of the concrete 5 to 6 to 10-story buildings that we have presently. So, it's up to you, youngsters, to do that, please, because it was only invented really at the year 2000. So, this is your material now. Run with it, please.
So I see here Göksun Hocam.
Yes, hello everyone, and thank you very much for your enlightening presentation. Actually, when you talked about the historical buildings in Istanbul, I started thinking as a historian. Timber had a very, backward image for modern people, let's say. The residents of Istanbul, because it was associated with fires, old style, old fashion, and concrete or multi-story buildings, living in the apartment buildings was associated with modern life, progress, hygiene, etc. So, of course, this is not the same timber we are talking about. This is engineered timber. But is there any image problem with timber? I don't know. Maybe in Turkey there is. I'm sure there will be resistance from people. maybe some will see it as a backward material, I don't know. But what is the situation in England, for instance, or in other places? That's what I'm curious about.
Okay, so in Scandinavia, they built 5 buildings, identical. The construction was identical, and it was a development called ICE, I-C-E, and the developer painted the first 4 all in white, so the walls looked like they were gypsum board, and the ceilings looked like gypsum board, and the floors were probably painted as well. I don't know what they did. They probably put carpeting down, but then they left one just as if it had just been constructed, and the timber was on the walls, the ceilings, the floors, and those sold. The others didn't. So that really tells you that younger people, young families, single people in cities and urban centers really understand the material well. It's not a marketing gag for them. They see that there's something more healthful, there's a response. And again, I was showing those slides about sort of your involuntary reflex and suppositions that you usually have that are based on what you're thinking. Well, they're supplanted by the way that you feel. And if you feel good about the material, which very many people do, it feels safer, it has an odor of the fresh woodland glade, then all of the other concerns disappear. It's a new material, so it's not going to look like timber houses, stick houses. It's going to have a modern appearance. In fact, it will look fresher than old gray concrete buildings, which people love because they had no other choices. And it was a product of, Corbusier's very clever marketing strategy to destroy cities, to say that I'm going to put you in a new, modern, clean, angular house. And then they were planning to wipe out the whole city, right? So it's kind of that way. It's kind of like, now we know that we love cities. They're places that young people want to be there because there's things that are happening. It's part of the social, awakening of people to want to live in cities. A little less so after COVID, honestly, but still the trying to regenerate the city and retask it for the 21st century for you, not me, but young people is really important. But what I learned over years from looking at old books of cities, they change so fundamentally, even in 50 years. If you went back 50 years later, there's incremental changes, but if you went back, the city would be completely different. And now you have an increase in population that's going to be significant. You will find that younger people are going to have an influence on the marketplace. I'm not saying that those clever guys that do concrete buildings aren't going to manage to keep the market down, but in most countries, I think people will find wonderful opportunities to build these types of buildings because they're greener and people like them, and there's science behind it. So you could say it's the new science, really, just telling you this is what modern life really should be: healthier, better for you, live longer.
Yeah, I agree. Thank you very much. You are young also.
I'm not so young, dear.
You don't look.
You're so nice. Get me that phone number.
Okay, thank you very much.
Thank you.
I think Nilay Hocam.
I think it is from before, Hocam.
Okay, Hocam. Okay, Hocam.
I think we are finishing now.
I don't know. Are there any questions? Otherwise,
I'm just looking at the comments.
okay. I'm just checking also here the chat box. Okay. So
Yeah,
So-
I'm looking at that now.
So
Okay.
That was it.
that was it. Yes.
Okay, I hope you guys had fun.
I
Anyway, it's
would like.
interesting. It's an interesting topic, and the thing that's interesting, when we started 3, 4, 5 years ago, you know, there was so much excitement because people thought, wow, this is a new way of looking at, you know, our cities and really trying to design buildings to be healthier and better places for people to work and live. Well, now we realize how bad the offices are because no one wants to return to them. And so it's a real challenge, I think, for designers to try to bring people back to these buildings, not by force, but because they have a desire to meet others and make them safe. But reading that, you know, you're 13% more productive by staying at home once a week, it really means that the buildings were terrible. They were just so terrible. So, you know, it would be good to be able to improve them, and maybe the use of material will help. But there's definitely has to be a sea change at what it is that people really want to get them to come back. Because only when they're happy are they really going to do good work for you. You know, you're going to engage their full brain, and in a competitive world, that's what you want. You really want people at the top of their game when they're working for you, rather than worried that the air quality is so poor, the air is so dry that you might get COVID or get some other disease. And it's an interesting world now. Challenge, but an opportunity, big opportunity. Okay.
Okay.
Demet Hanım, do you?
Yeah.
Yeah, we did that half an hour ago.
So Demet Hanım, do you have questions? No.
No,
Okay.
I don't
Okay.
have a question, but I want to say something maybe.
Okay.
I would like to say my special thanks to Kevin.
Thank you.
He shared his all experience and knowledge with us, and I believe something changed in our students' mind. They will think about more about timber and timber design solutions. And last week and this week, with the questions, I understand here we have to talk about timber more than before, because they have some questions, some basic questions, how about they use timber in construction. They don't know many information about CLT and engineered wood. I advise them they can search on web, and they can find your videos on YouTube also. And I think that's all for me, Hocam.
Okay. So then some closing words. Dear Kevin Flanagan, it was an impressive presentation and talk, a very holistic view. You presented really everything. Thank you for that. We have a little tradition in ArchiDesign talks, BAU, Faculty of Architecture and Design. We are donating in our guests' names. A donation has been made in your name to Save Foundation, helping underprivileged children for equality in education. Thank you again.
That's very good. Thank you very much. Thank you for having me.
Thank you.
Thank
We
you.
can talk about how we say. Sure. Okay. Good. Thank you.
Thank you.
Good evening.
Thank you
Good
very
evening.
much. Bye-bye.
Bye.
Bye.